Hello, good morning all of you. I am Ushadi, working as selection grade lecturer at Government Women's Polytechnic, Ramnagar. I hope you are familiar with C programming little bit. In today's session, let's learn more about C programming. All this time you have come across the basics of C, that is writing a very simple C program that is going to be executed in a straight line execution manner. And in today's class, we are going to know more about C programming, looking into the decision making and branching structures. So here, as you see, when do we make the decision making? When we have more than one option. So here you see we have multiple options and we need to make a choice between these options. Before getting into the decision making and branching structure, let us look into some of the operators that C supports in association with this. First thing is the relational operators. C supports 6 different relational operators, that is equal to, not equal to, greater than, less than, greater than or equal to, or less than or equal to. The equal to symbol in C is going to be written as a double equal to symbol without any space here. And we have a Boolean expression that is going to be used along with these relational operators. That is when we say A is equal to B. So if the variables A and B have been defined values such as 10 and 20 respectively, then A equal to B would result in a false value, that is a 0 value. In the same manner, all the other Boolean expressions would yield certain results. In addition to the relational operators, we also have the logical operators that could be used in the conditions that we are going to use in the decision structures. The logical operators that are supported by the C programming language are the logical AND operator, the logical OR operator, and the NOT operator. The AND operator is denoted by a double ampersand symbol without any space in between, and the OR operator is represented by a double more operator, and the NOT operator, that is the logical NOT, by an exclamatory mark. And as you see, both the AND and OR operators are binary operators, so it depends on the value that the operands hold along with them. So if you define A is equal to 1 and B is equal to 0, then A and B, that is 1 and 0, becomes false, and 1 or 0 becomes true, because you know about the and OR operators that you have learnt in your digital electronics. And the NOT operator is a unary operator that operates on a single operand. So you have NOT of A and B, which results in true because A and B was a false. So looking into these different types of operators that C makes use of in the decision structures, let us take a closer look about the decision making, how the decision is handled. In the flow chart, you come across a condition. Here we check for a condition, whether the condition is true or false. Based on that, suppose the condition becomes true, the conditional code is going to be executed. If the condition becomes false, then the conditional code is skipped and the statement following the condition code would be executed. In C programming, we have 3 different decision making and branching control systems. Here you have the if statements, the if else statements, and the nested if statements. Coming to the if statement, we have a condition that is checked and a condition code that follows if the condition becomes true, and following that the rest of the statements in the program. So if the condition becomes true over here, the condition code is executed. If the condition becomes false, it is simply skipped and the following statement would be executed. One important thing that we need to know here is the C programming language assumes any non-zero and non-null values as a true value and any zero or a null value as a false value. So let us look at the syntax of the if statement. You have an if condition. So this condition is going to be a Boolean expression or a test expression also. You can call it as either a conditional condition or a Boolean expression or a test expression. Following this condition, we specify one or more statements. So if the condition becomes true, the statement or the statements that follow this condition are going to be executed. Here I call that if you have a single statement, I would call it as a simple statement, and if you have multiple statements within this if block, I can call it as a compound statement. So if it is a compound statement, meaning that if you have multiple statements, then those statements must be enclosed within a brace like this. If you have a simple statement, then this brace becomes optional. Let us have a look at an example making use of this if statement. Here we have a program where we have defined variables m and n whose values are defined as 40 in the beginning, and then we are checking for the condition if m equal to n. As we know, since the values of m and n are both equal, then it gets into the if code over here, meaning that printf m and n are equal would be executed. So our output would be the same, that is m and n are equal. Let us look at another example wherein we have one variable called a whose value is defined as 10, and we are checking for a condition if a is less than 20, which happens to be true in our case. So it gets into the if code over here and the printf statement is executed. So that means a is less than 20 has to be printed. Following the if code, that is, you have a brace over here, so that finishes our if code. Following that, we have another statement called printf value of a is, the value of a is going to be printed. So our final output would be as you expect, a is less than 20 and value of a is 10. So let's take another look at the program. Here we have one single variable where a is defined as 10, and we are checking with a condition if a less than 20. Then since the condition is true, it gets into the if code and the statement is executed. Following the if code, you have another statement, that is, we are printing the value of a. So our output would contain both these statements. The next variant of the if statement is the if else statement. So here, based on the condition, whether the condition is true or false, the if code and else code have been written. So the condition becomes true, the if code is going to be executed, and the condition becomes false, the else code is executed, and then it would be followed with the other statements of the program. The syntax for using the if else statement would be as follows. That is, you have if condition, then follows with few statements, that is statement 1, statement 2, etc. So since there are multiple statements over here, that is a compound statement, we are enclosing them with a brace like this. And then we have the else part over here, that is when the condition is false. It gets into the else code, that is statement 3 and statement 4 would be executed. So at any one point of time, either of these statements would be executed, that is the if code or the else code part would be executed. Let us take a look at an example based on this. You have a program wherein we have defined two variables m and n, whose values are defined as 40 and 20. And we are checking for a condition if m is equal to n. Here the condition becomes false because 40 is not equal to 20. Hence it does not execute the if code. It directly gets into the else part over here, and then it looks into this, that is m and n are not equal would be executed. Till now you have looked into a simple C program. Here you would be wondering why this return 0 is given at the end of the program. That is because C is a procedure oriented language. We know that. So in a procedure could return a value or not. That is, it may return or may not return a value. Since here we are saying that the main procedure has to return an integer data type value, we are giving a statement that is return 0. So 0 is an integer data type which is being returned. As the program does not need to return any values, since we have given this int over here in the beginning, that is the return data type, we are giving a return 0 over here. So here, as in this program, what is the output you expect? The output would be m and n are not equal. Another example dealing with the if-else statement. You have a variable, an integer variable, which is defined with a value 100. And we are checking the Boolean condition, that is if a is less than 20. The condition is false, so it would not get into the if code. It would get into the else code, wherein we are saying printf a is not less than 20. Following the if structure, we have another statement over here, that is printf value of a is, we are printing the value of a over here. So that is why the output, can you guess? The output would be a is not less than 20 and value of a is 100. So look at the program once again. You have an integer variable a which is defined with a value 100 in the beginning. Then you are checking with the condition if a is less than 20. Since it's not less than 20, it does not execute the if code. It jumps into the else code and prints the statement, and then it comes out of the if block and then prints this statement. So your output would be a is not less than 20 and value of a is 100. The next variant of the if statement is the nested if structure. If we have multiple conditions to be checked simultaneously, then we may as well put all these conditions in what is called as the nested if. That is, you can use one if or else if statement inside another if or else if statement. And this is important to be noted, that is, in case of a nested if, you will have number of if statements along with a number of else statements too. So often we get into a confusion that which else must be combined with which if. There is a very simple rule that we are going to associate the else with the most recently unpaired if statement. So with an example, maybe this would be more clear. Now, getting into the syntax of a nested if, you have if condition 1 followed with another if condition 2. So there are two different conditions that are being checked. Following with that statement 1 else statement 2. So here, if condition 1 is going to be evaluated to a true value, then it would be getting into the inner if, that is condition 2 is going to be evaluated. And based on the value that we get out of the condition 2, that is if condition 2 evaluates to true, then statement 1 is going to be executed. If condition 2 becomes false, then statement 2 is going to be executed. So overall, when condition 1 and condition 2 both becomes true, statement 1 is going to be executed. Otherwise, if condition 1 is true and condition 2 is false, statement 2 is executed. What if condition 1 itself becomes false? So here you could have another else statement following this. So any statement following this else statement would be executed in case condition 1 is going to be false. An example to illustrate this nested if structure: we have two variables, an integer variable a with value 100 and b with value 200, and we are trying to test a condition saying that if a is equal to 100, which happens to be true. So it gets into the if code, where in the if code you have another if condition where if b is equal to 200, that also happens to be true in our case. So the statement within this if code is going to be executed. So value of a is 100 and b is 200 is going to be executed. So there ends your if block, and the next statements following the if block are the printf statements again, the exact value of a and exact value of b. So what would be your final output in this program? Your final output would be these three statements, that is value of a is 100 and b is 200, and exact value of a is 100 and exact value of b is 200. Look at the program once again. You have a nested if structure. So the first if evaluates to true, it gets into the second if. The second if also evaluates to true, the if code block in the that is the inner if is going to be executed. If this is going to be false, then if you had an else part over here, that would have been executed, but we do not have any else block over here. Let's take another example, where this example is to find the largest of three numbers. You have three integer variables a, b and c. We are trying to input the values for all these three variables by making use of the input function scanf. Then we are checking a condition that if a is greater than b. So if that happens to be true, then the another variable that has to be checked is the c variable. So in the inner if, we have if a greater than c. So if both these conditions be true, that is a greater than b and a greater than c, then it is obvious that a is the largest element. So printf variable a is the largest would be executed. In case A is greater than B happens to be true, and A is not greater than C happens to be true. That is, A greater than C becomes false. Then we have the else code that is going to be executed. So variable C would become the largest element. So here we have in case where A is not greater than B. So we get into the else part over here and we check if B greater than C. So here if A greater than B becomes false, it means that B is greater than A. Next we need to check B with the variable C. So we say if B greater than C, it means that both the conditions, that is B is greater than A and B is greater than C, has happened. So B becomes the largest element. Otherwise, B is greater than A and B is not greater than C, means that C would become the largest element. So this is a classic example of the nested if structure, where we have used an if within an if and else for the inner ifs over here as well as the outer if. So as you see, often we get into a confusion that where we need to use the brace and where not. If the braces are not used properly, then you would end up with an error saying that you get a misplaced else. So be careful when you are putting the brace. Okay, here we have started with a brace for the outer condition, that is the if statement, and then we have ended over here, that is over here. Okay, and in between, since we have single statements over here, you need not put any brace over for that. Another example where we are making use of the logical operators along with the relational operators. The program is intended to be the same, that is to find the largest of three variables. So here we are checking for the condition if A greater than B and A greater than C. So if both these conditions become true, then the statement following this would be executed. So A becomes the largest element. Else if, that is B greater than A and B greater than C, then we have B is the largest element. If none of these conditions are true, it means that C would be greater than A as well as B. So without checking any condition, we simply write the statement that C is the largest element. Whether you use the logical operators or only the relational operators with the nested if structure, whatever it is, it depends on the programmer to decide upon which structure is the best. Now as you see, here we are checking with multiple conditions. So in a program where we are making use of this logical operator, we are checking for 4 different conditions, that is A greater than B, A greater than C, B greater than A and B greater than C. So these are the 4 conditions that are being checked over here. Previously, if you just get into this nested if, you would be checking for conditions if A greater than B, A greater than C and B greater than C. That is 3 conditions you are checking. So the number of conditions we are checking is lesser in case of the nested if. So it means that we are making use of the processor time more efficiently in that case. This is just an example in a very simple program as this, but just think about a very complicated program involving thousands of lines. So it is always the programmer who has to decide upon this. And another variant in the if statement is the Elsif ladder. The Elsif ladder is going to be used when multi-path decisions are involved. That is, what is a multipath decision? It is nothing but a chain of ifs in which the statement associated with each else is an if again. Let's look at the syntax of an else-if ladder. You have if condition 1. So if condition 1 becomes true, then statement 1 is going to be executed. If condition 1 becomes false, then we get into the else if part. So again you are going to check another condition, condition 2. If this condition becomes true, then statement 2 is executed. Even if condition 2 becomes false, then it gets into the else part, where again you are going to check for another condition 3, and if this becomes true, statement 3 would be executed, and so on it continues. And the last part over here would be a default statement, that is whether the condition is either true or false. Whatever, you are not going to check with the condition, but the default statement might have to be executed, following with the next part of the program. So that finishes the entire if block over there. Let's have a simple example over here. This is just a sample code where the entire program has not been coded for you. You will just have to assume certain variables that have already been defined earlier. And here we are comparing with a condition: if marks greater than 79, grade is equal to distinction. So if this condition becomes true, the statement here would be executed. If that is false, then it gets into the else part and another condition is checked, and then a value is assigned to this variable grade. If that condition also becomes false, then it gets into another else part over here and checks with the condition. If this becomes true, then another value, that is second class, is assigned to the grade variable. If this also happens to be false, it gets into another condition. So this happens until the entire else if ladder has been executed. Or suppose when you have some condition that has been true, that is, suppose you have marks greater than 49, then grade will be assigned with a value second class and it would directly come out of the if block. So once it comes out of the if block, the value of the grade would be printed over here. So that is why we call it as a decision and branching structure in C. So suppose some decision is taken and then it would branch directly, skipping some of the statements within the program. So now let us have some examples based on the if statements, whatever we have learnt till now. Can you just expect or guess the output of the following program segment? You have a variable m which is defined with a value 5, and we are checking with a condition: if m less than 3, we are printing the value with saying that m plus 1 has to be printed. Else if m less than 5, print a value with m plus 2. Else if m less than 7, print value m plus 3, else print value m plus 4. So what would be the output of this program? We have the value defined for m equal to 5. So the first condition becomes false. And the second condition over here also becomes false because m value is 5, not less than 5. And when you get into this part, that is else if m less than 7, yes, it is true. So the value of m, the output result would be m plus 3, that is 5 plus 3 would be 8. Now look at this example. Could you guess the output of this segment? You have a variable x defined with a value 0, and you are checking with a condition if x greater than or equal to 0. And then again you are checking with a condition if x greater than 0. You have two parts over there, that is the if code and the else code over here. So what would be your final output? You have x equal to 0. So in this condition, if x greater than or equal to 0, if you are evaluating, this becomes true. It gets into the next if condition, if x greater than 0, but here we have defined x is equal to 0. So this if code is not going to be executed. So it gets into the else part and prints saying that the number is negative. So your final output would be printed as the number is negative. Another example, what is the output of this following segment? You have two variables x and y, where x has a value 10 and y has a value 20. You have a condition which involves both relational operators as well as the logical operators. So you are checking for x less than y, which happens to be true in our case, that is 10 is less than 20. Then we have the logical OR. We have another condition, that is x plus 5 greater than 10. So x value is 10 and we are adding 5 to it, so 15 greater than 10. So here both these conditions, that is x less than y or x plus 5 greater than 10, are evaluated to true values. But since we are making use of this logical operator OR, once if one of the operands becomes true, it never goes to check the other condition. So here once we end up saying x is less than y becomes true, then the C compiler doesn't go and check the other condition. Inevitably it gets into the if block. So here it prints the value of x over here and returns to the main program. So on the whole, let's just summarize what we have seen in today's session. We went through the decision making and branching by making use of the different if structures that C supports. They are the if statement, the if else statement, the nested if statement. Apart from this, we also have the Elsif ladder. In the if statement, you have just one option. So you just specify the condition, and if the condition is evaluated to true, the if code is going to be executed. Otherwise, the statement following the if block would be executed. Next, you have the if else statement, where you have two alternatives or two options. So you are checking with the condition. If the condition becomes true, the if code is going to be executed. If the condition becomes false, the else code is going to be executed. Then the nested if, where we are going to put more than one condition within an if block, that is if followed with another if or else if conditions. So if the first condition is going to be evaluated to true, it gets into the second if block. Then in the Elsif ladder, you have multi-path decision that is going to take place. So you have an if condition, else if condition, etc. So there we finish our session on the decision making and branching structures. Thank you all.